Hi, in this lecture we are going to discuss about defensive programming, in particular in the case for dynamically typed object-oriented language. We are going to discuss about spurious checks, in particularly for the case when we are going to validate data in our methods. We are going to discuss about the impact of those type checks and checks in dynamically typed languages, and we are going to discuss the impact of testing to avoid those checks. Before going into checks, let's discuss a bit about this method, the assertion method that we're going to use through the slides. So this method is an assertion method where objects are going to assert that a certain condition is true or false, and if false, we are going to throw an exception. Yeah. So this method assert description, we are going to be able to use it like this. So self assert condition description, and then what happens if it fails. Yeah. So we check the condition, and if it fails the condition, we are going to throw an error with this message. So it's important to understand that this method will change the control flow. So if the assertion fails, the rest of the method in the caller will not be able to execute. Let's see this with an example. So here, for example, we see in the context of a graphics framework, a method that sets the padding inside an object. So this is just a normal setter. So here we take an argument and then a parameter, and we are setting it into a local variable, an instance variable. And before actually setting it, as in a normal setter, we are going to assert here that the padding, that the argument we are receiving is not nil. So in that case, if the padding is nil, we are going to throw an exception, checking that the padding must not be nil. The question that we can ask ourselves is this assertion here worth it? So let's analyze it a bit. First, we need to think about the runtime cost of such assertions. Of course, in many different languages, assertions can be optional. We can turn them on and off, and for example, avoid them to be compiled at all at the end. So for example, we could think that they are never executed in production. So in that case, they don't have any runtime cost. So that could be, for example, a potential benefit. And they could also help us track problems and stabilize the code when developing. So we don't want to have nil as a padding in any object. So let's validate it right away. Now, let's think about the same code, but written a bit differently. Instead of having an assertion error, we are going to just check it directly. We are going to check if the padding is nil, then we are going to throw an error. So what is the difference between the previous example and this one? Of course, the goal is the same. We don't want that the padding is nil. We don't want our code to be broken because the padding is nil, actually. Because if we avoid padding to be nil, that means that our code in the rest of our program knows that the padding can never be nil, and it can be simpler code. I refer you to the null object sections and avoid nil check in the other lectures. Now, of course, here we are checking that the padding cannot be nil, but that it doesn't avoid that we set any junk object as a padding. So we could, for example, say padding colon, and we could put string here. So if we put string as a padding, our code actually will be broken too. So why not checking that this is not a string, or this is not some other object? So this means that actually that this test here, this check, is not enough to solve all our problems, and maybe it's not worth. Here is a proposal for a better setter method. This is just taking the parameter here and setting it into the instance variable without doing any checks. Of course, a padding is still expected to not be nil, but it is also expected to not be string and other invalid padding. So what are the advantages of this? Take a couple of minutes and think about that. We're going to discuss it in a couple of slides. before going into that, let's see another example. So here we have, for example, this source method in an event, and it is also implemented using assertions. So we are going to assert if we have no source, then we cannot access the source. So this is defensively checking that you cannot get the source out of an object if it doesn't have a source. Again, these assertions are conceptually optional, so this code could not be there, and the code should be still okay. But it still looks like a leftover from debugging, because this will just throw in development an assertion error. If we wanted, for example, to catch that exception because it's a valid exception in the domain, then maybe it could be better to make it an explicit exception. We could, of course, turn that code into this just by removing the assertions. And then this code now, it's an explicit check that is, of course, mandatory in all our code. So then every time that we are going to access the source of an event, we are going to check always if it has a source, and in case it doesn't, we're going to throw an error. We can later replace, for example, this error with a domain exception for our particular case. What this actually changes from the previous example is that we can catch in the caller, or even in any of the callers in the call chain, we can catch the error if we need it. Of course, the reader knows that there is a check for real. This is actually a domain decision to avoid people getting the source if it is not there. Of course, it would be better and simpler to always have a source. But if the domain actually supports that having a source is actually an optional part of the domain, we should think about that. Of course, if having a source is optional, we can think of replacing this with a null object. Another variant of the checks that we saw before is to check explicitly for types. In this case, we are checking that our padding is of kind BL padding. This is equivalent to doing an instance of check in Java. What are the benefits and the disadvantages of this solution? First, we have to understand that making an instance of check or an is kind of check is slow, because it has to traverse the entire hierarchy to understand if the object is actually of the requested class. One of the other disadvantages of this solution is that it prevents to extend the program with polymorphic objects. Imagine that tomorrow I would like to have a different padding, but without sharing the hierarchy of the BL padding. I could implement a BL padding object or a similar object to BL padding that has exactly the same interface, understand the same messages, but it doesn't inherit from the BL padding class. In such a case, I would not be able to use my padding in this code here, because this code is actually checking that the object needs to be in the hierarchy of BL padding, and it's not checking that it needs to implement the same interface. So this check is preventing me to implement polymorphic objects. As a conclusion, avoid using optional checks that can be used mainly for debugging purposes, or remove them after debugging. Also, avoid using explicit type checks, because they prevent code evolution. And favor tests, because actually what we have seen as assertions in the code and checks in the preamble of the methods could have been different tests in our source code.